Assalamualaikum warahmatullahi wabarakatuh. So good morning everyone. So today I would like to continue our class manufacturing engineering. Before that, we already have last week we already have a small discussion about introduction to the manufacturing engineering. So wait, I need to change the slide. Okay. All right. The fundamental of manufacturing engineering. So we use this textbook. So I already shared the textbook in the below. So I also use this one, Automation and Production System, Computer Integrated Manufacturing by British Hall. So you can also refer to this one. So even though we also have manufacturing system engineering and material and process manufacturing by Willie. So you always can refer to both of these books as well. Okay. So today's topic is a production system. Production system. So what is the production system? So production system include the main two is facilities and manufacturing support system. So this one we already discussed about the manufacturing, the meaning of manufacturing itself, and then the manufacturing process. So the process to make the things from the drawing. So we set up the several process. So that several process will be manufacturing system. From the manufacturing process, we have a manufacturing system, and then production system, the collection of people, equipment, and procedure. So we have facilities in the production floor side. We call it factory. We have equipments, they have machining, they have toolings. So the procedure like MOP, machine operating procedure, production operating procedure. So that one under manufacturing support system, they we use to manage the production to solve the technical and logistic problem encountered in order material moving work through the laboratory, through the factory, and ensure that product meet quality standard, which include product design and business function. So these two related they have interaction each other. So the manufacturing support system will what we call it will monitor, will control the people inside the facilities, inside the plant, and also control the equipment and machinings. So the facilities and manufacturing support system is the collection of the production system as well. And then in modern manufacturing operation, the portion of the production system are automated. And the automation always semi-automation and automation. They use computer to manage to make sure the automation can work, can perform inside the manufacturing operation. And however, it include people make the system work. So the operation, they need people to control, to make sure the operation, the manufacturing or automation or semi-automation can work better. They still need the people. So this one, we call it white collar workers. White collar workers as a professional staff, professional operators. They're responsible for the manufacturing support system. They're responsible for manufacturing support system. The blue collar workers, that is a direct level people, direct level workers. They are responsible for operating the facilities. Normally, they are skilled workers. They are skilled workers. They used to operate some specific machine, and they're responsible to operate the facilities in the factory. So these two, blue colors and white colors worker, there is as one part of production system. So this is the summary for the production system. We have manufacturing support system that is accumulate with the procedure, set of procedure, SOP, MOP, to run the factories with the machine, equipment. So this equipment and machine will still need help from the people to operate. So the factory, this one consists the people. This one also have people inside to do the procedure, whatever lah. And then these two, they are interaction each other. They interact each other. So the manufacturing support system, normally they not directly involved with the product, but they involved with the supporting staff inside the factory, supporting the machine inside the factory. Okay. So this is a typical organization chart for manufacturing. So we have a production manager here, production manager. So under that we have production planning. Wait, we have production control and also production implementation. So these two will have this part involved with the production implementation. So they have operators, foreman, department manager. They involved with directly with the production line side, production side. All right. Then we already discussed this one last week. The range of product quantities, product quantities produced in the factory can be classified by these three range. So we have a low production, medium production, and high production. So the low production, the quantity is always range around 1 to 100 unit per year. And then medium production, we have quantities around 100 to 10,000 units per year. And then high production quantities over than 10,000 units up to million. So these are three boundaries we always refer and use. So normally this one based on the textbook what I refer, they use this range as a classification for the product quantities, but some book they have different range, but they always refer to the low, medium, and high production. The quantities might be slightly different, but the base what we refer is the quantities that can highlight the low production medium production and high production clearly. And then we have product variety. Product variety refer to the different product design type that are produced in the plant. So the variation of product normally based on the shape, size, model, function. So they are making for the different market, different target people. So that's why they have a variation of the product. So normally this one will affect to the production floor or design section or manufacturing section to produce the part with the various function, various varieties. So the correlation between product variety and product quantity is the inverse correlation. There is a relationship between product variety and product quantity. So as we can see here, the highest variation of the product, the lowest quantity that can be produced. So this one we call it low production. And you can see in the middle, 100 to 10,000 units per year. You can see the median production. This one is slightly have variation, not high, not low. They have slightly have a variation, but the quantity is 100 to 10,000. We call it the medium production. So then we have high as well, high production. So this one you can see that the variation is slightly lower, low variation with the high production unit. So up to 10,000 up to million unit per year production. So we call it this on high production. So this product variation. So this product variation normally we base on the we can call as a hard product variety and soft product variety. There is two name given in this textbook, so we can always call this name hard and soft product. So for the hard product variation, normally they have a slightly different, huge difference with the product itself. So the hard variation is based on the characterized by the low proportion of common part among products. So they always using the specific part for their own model or own part, own product. So that in this case, we can see an example from this Volvo car and this truck. So this one, we call it hard variation because they have a huge difference between this one. So when we manufacture, we cannot use the same machine or jigs or material as well. So normally they have a specific, for example, you can see here bumper, lamps, door as well. So the frame itself, engine might be also different because the torque of the engine, the horsepower, the force, they are different. So they make for the normal use, this one for the heavy use. So you can say this one hard product variation for the Volvo. So they might be have a separate line for manufacturing of this one. And then example for the soft. Soft normally they use common part in the production. So you can see here rover car here, they have several model and type they produce. So you can see this one have a moon roof, this one have a open sunroof, moonroof. They have a different order grill. So in terms of accessory also different. So they are quite different on the several part, and then they have a common part as well. So they can produce in the high volume production. That's why they call it as a soft product variety for this one. In late 1919, this car is very famous. They can produce around 40,000 unit per year. So that's why they cater on that one. They produce a lot different target people. They have slightly different models. For the low quantity production, we also call this one job shop production. Which refer to the making the low quantities. So in the job shop production, they always have a specific machine, specialized tool to customize the product. So normally we use a general tools to complete the product, or we can use to produce also the product with the complex design, complex. They have a complexity like space, aircraft, locomotive, ship. So this one they have the product, and then the operators bridge the machines, and then they will do the production at the site. So the product stay at the one space, at the production space. We call it job shop. And then customer order for this kind of item are often special, and repeat order may never occur. So they also refer to this one, the special orders, handmade order. And then if they want to repeat order as well, they have a long cycle, like 5 or 7 years, they might be repeat the order, but repeat order may never occur as well. So equipment in job shop is general purpose, and use high skill workers. And then production remain in single location, like when we build like a ship or aircraft, the worker will bring the equipment to the place. And then, for example, this is building the ship. So the worker will bring the general equipment, this one general equipment. They do the assembly here at the deck, at the engine side, and then they do they focus on the product. They just they go around the product. The product fixed at the position. So sometimes they will call it is a fixed position layout for this job shop production as well. So another example, we have a plane. So last class I already show you the aircraft, Boeing 747. How they make it. There is also a job shop or fixed production layout, ship, locomotive, train, space, and then the individual part that comprise this large product are often made in the factory that have a process layout. So this one we refer also process layout, because in which the equipment is arranged according to the function of type, function or type. So the product we will move, will move or will focus based on section. the process. So for example, this part of the layout, they focus on the building the engine, for example. So they do a bulk production to process in this section, and another section similar, they use another machine, for example lathe machine, to produce another product. They have for example in the grinding machine, so they divide by section, so they call it a process layout. And then yeah, the different of part each require a different operation sequence and usually in batches. So they have a different part to in this different section, and then they use also specific tool, specific machine. Of course, the worker also they have a different skill to work here. And then process layout, it's for flexibility. It can accommodate the great variation, variety of the alternative operation sequence for different part configuration. So disadvantage of is that the machinery and method to produce the part are not designed for high efficiency. So even though they don't design for high efficiency, but the skilled worker used to concentrate to produce the high quality part as well. They can use this process layout to produce the high qualities product. But they focus on the volume as well by batch, and then they can bring this process, this product to this fixed or job shop layout to assemble here. So for example, the engine part they produce in the process layout, and then they can bring here to assemble to have a final assembly in the fixed position layout. So medium quantity production. So this one consider hard product variation. The traditional approach in batch production. So they focus in batch production, in which a batch of one product is made, after which the facilities is changed over to produce a batch of next product and so on. So the order of each product are frequently repeated. So the production rate of the equipment, the bigger than the demand of the rate of any single product type. The same equipment can be shared among multi-product. So normally they use a same machine to produce, but they need to change the special tool like jig, like tools, toolings to do a suitable process for the product variation. So they can do the change over the tooling as well, the equipment on the machine, but they take time. They take time, some time to run or to fix to cater the changeover. They also have to need maybe need to reprogram the machinery. So soft product variety, so extensive changeover between the product style and next maybe not required. So the soft product variety, they also use the similar machine to produce the high volume production. So the equipment maybe they not change. If they have a changeover, then not required the long time to do it. So no need to do reprogram of the machine. So they use this what we call it, the term of this one is a cellular manufacturing. The cellular manufacturing is often associated with this type of production, soft product variety. So each cell is designed to produce a limited variety of the product. There is the cell specialized in the production of the given set of the similar part, or produce the product according to the principle of the group technology. So we can produce the product without chain over, and then not required the reprogramming as well. So we can produce with the high volume production. So that's why we call it soft product variation. So this is a example for the cellular layout. We have U-shaped production system here. So the workpiece, workflow, material, we come in from this way, and then we have machine and operator. They have a conveyor to move to workpiece to the machine side. So the operator will do it the process until we have a complete part here. So from here to here, we call it machine cycle time, and then this time is operator time or machine time. So this is a cellular type layout. So we can produce a soft variation product with a high volume production as well. So high production, others we call it mass production. So this one is up to 10,000, 10,000 up to million, more than that, more than 10,000. We call it mass pro. Mass pro is a mass production. So high demand rate of the product. And then production facilities is dedicated to the manufacture the product. So they have two categories to distinguish this mass pro. So we have based on quantity production, and then it's based on the flow line production. So quantity is always referred to the process layout that involve the mass production of the single part on the single piece of equipment, which involve a standard machine equipped with the special tooling. We have special tools. So this can be example like die. They process to produce for example they have to produce the frame. They use a special die. So they need to press the process. So they press the steel. They will produce the part based on that specific machine. They occupy with the special tool, and then usually this one we call it for process because they focus on the process layout. And then for flow line production focus on the product layout. They involve multiple workstation. They have multiple workstation arranged in sequence. So they have like you said just now, I show you. They have a straight line. They have a focus on the every station to assembly the part, and then they have sequence to complete the product. And then this is a product layout. So they just take from U shape and then to straight line. They have conveyor, and then the product will come from will flow from here, and then we'll have a finished good here. So there is a product layout for the flow line production. And product layout normally use the conveyor. They use a conveyor. They use a specific machine. So each station they have small amount of the total work to complete for each product. So normally we use a line balancing. For example, this operator will work for 30 seconds, for example, or 1 minute. So to balance up the process, the line balancing will make equally by each operator. So they will do the process based, they will divide based on the cycle time for one operator. So this one, for example, 30 seconds, this one also around that one, 30 seconds, 30 seconds, 30 seconds. So we can produce the product with the correct sequence and flow. So example of flow line production is a car assembly, household appliance, electronic part. So no variation of product. They have focus on the single product, a single move production line. So that's why we can call it mass production for high volume production. So however, to success this production layout, market a given product. To successful market a given product is often necessary to introduce model variation. To introduce model variation so that is satisfied the customer. Example, car coming off the assembly line have a variation in option, and trim represent different model of the same basic car design. So they can use a different model, different product, but the basic car they will produce in the product layout or fixed line layout. But at the end, they need to do the variation of the different model in the separate line, separate process. So that is an example for the bottling process in the Coca-Cola, the Coke. So they use bottling in the production line. This one we call it product layout. So they just do bottling, labeling, capping here. So they all use automation system. Car as well, they manufacture in the assembly line, and then they have do different modeling for others in the separate unit to differentiate the model of the car, electronic part. And then I used to explain this one. They have variation, the correlation, inverse correlation between product variety and product quantities. So from this graph, this layout, you can see that the low production, we use a job shop. We also call it a fixed position layout. And then we also can use a process layout here. So process layout. So in the medium product variety, up to 100 to 10,000, we call it a medium production. And then we use cellular manufacturing or batch production. So this one also process layout or cellular layout, like you shared just now. But for the higher production, we have mass production for the quantity 10,000 up to million. So we have focus based on product or process flow, flow line. So this is a mass production. So please remember this one, the type of facilities and layout used for different level, production quantities and production varieties, based on the inverse correlation just now. And then manufacturing support system, we go for manufacturing support system. So to operate the production facilities, we always need the people to do, to organize, to monitor the process, to design the process, the equipment, plan control, and the production orders. And then the satisfied product quality requirement as well. So these functions are accomplished by manufacturing support system. We have manufacturing support system. And then the peoples in the production facilities, in the factory level, they focus on to operate the what you call it, the facilities, the machining. They managed by the production operation or production engineer. So the most of these support system do not directly contact with the product. So the manufacturing support, they're not involved directly with the product, but they plan and control it progress through the factory. They make the procedure, they make the layout, the SOP, MOP for the machine inside the factory. So the people inside that factory will involve directly with the product and follow the procedure that making by manufacturing support system. So manufacturing support involved in the cycle of information. So they pass information through the procedures. Manufacturing support involved in the information processing circle. So the cycle in the typical manufacturing firm can show by this one. So you can see here the process always start from the customer side, customer ordering through the business function or business unit or marketing. So they come from here, they will end from here as well. So customer ordering, they will get order from customer, and then order based on the existing product. For example, they just go for the production side, or they have new product to give for product design, manufacturing planning, manufacturing control, and then go back to the business function and deliver the product to the customer based on their order. So we go one by one. This one for the business function, they normally beginning of the process and then ending of the process information processing cycle. So included are sale and marketing inside this one. Sales focus, ordering entry, cost, accounting, customer billing inside the business function unit. So the order of the product, the order to the produce of product typical originate from the customer and proceed into the company to the sale and marketing department of the firm. So they pass the order to the others different department in the company. So the production order will be one of the following form. So number one, they order to the manufacturing an item to the customer satisfaction, an order to buy one or more manufacturer proprietary product, and internal company order based on a forecast of future demand for property product. So this one, the information flow will I just show the relationship between from this photo. So you can see this one is the customer explain this one to the production side, and they have understand the what we call it, the discussion, the requirement or need from customer. Actually, this one is what customer really need. So they need the swing. So the business side or sales marketing engineer will prescribe what they explain, and then they will discuss with the project leader. So when the project leader understand that, they understood in the different way in terms of engineering. So they they have this idea how the product leader understood the process or the requirement or the demand from the customers. And then the analysis will do for this particular product. So they do some analysis and simulation. If the tree break off, for example, if they use another support, for example, they do some analysis to sustain the product. And then the programmers write the programming, so to make sure this can be function as a swing. So if not, the programmers should do concentrate until they have a complete version. And then business consultant, the business people always describe with the huge, what we call it, exclusive version. So we have this swing with the comfort, with the something can be feel better when we use our product. So that is how businessman or business unit consultant do this description of our product, of a company product. So when they do it, they have another process inside the company as well. So not only for the design unit, for the marketing unit, they have also for the billing unit. They have another installation, operation installation, production side to see their problem, and support department. And this is actual what the customer want. They want to use the product. They want to use and to feel better when they use the product that they order. So our task is to translate from the customer demand or customer requirement to the engineering product, or the product where it can comfort to them and can have a value, can be sell back to the customer. And then of course we run a true process to make sure the product can be produced by our company and delivered to customer based on their requirement, their order. So that is the customers to the product design. So product design side, they have to have a task to design, to translate the customer requirement. If the product is to be manufactured to the customer design. So normally when we get order from customer, they also do give their own design. On that time, we can design, we can produce, but no need to design their product because they already pass over to us the complete design. So yet we need to see the design. Either we can produce by our own facilities inside our factory. If we can do that, we can straightly pass over to the production engineering to study the machine, the capacity, the capacity of our machine, and then the materials, the material, the supplies. So if that one can proceed, we can do a mass production for their drawing. But in this time, we not involve the product design. Product design not involved because the design already completed. But if we get the specification, the specification from the customer, So if you get the specification from the manufacturer, for example, we need to do a product design from beginning in the product R&D department. So product design department, maybe to do initial design, need the normal process until we can pass over the complete design to our production site to produce, to manufacture the product. So this is when we get our order from the customer based on the specification requirement. But if the product is proprietary, we have the customer, for example, they have their own product already. They don't have drawing, they have product, they have pattern on the product, but no complete drawing, no assembly drawing, for example. So we need to pass over to product design or R&D department to do a design, to do the research and to redesign the product based on their pattern, their product as well. So a new product design often originate in the sales and marketing department. So some customers, they just give an idea to produce, to come out with the product for their company, for example. So this is totally new product. So the sales and marketing department normally coordinate to produce or to discuss this one with the engineer at the sales, the company, the customer side, and then we will pass over the information to the product design department. The department involved in the product design may also include, so others than product design, they have the design engineering, and then also prototype shop department involved in the product design activities. So this is just to show you the organization of the typical market department for the marketing. So you can see here, we have under marketing, we have market research to do to gather the information, potential, the customer ideas. There is a market research to see the product life cycle. So they have market research. And then we also have promotion, advertising to advert the product, and then distribution and handling, transport, warehouse, selling, sales, training, planning, and then product planning. So product selection, product features, pricing, and product servicing. So we have this typical department inside the marketing. So others, we have a purchasing, manufacturing, and finance. So normally this general basic for the sales and marketing, but some company, maybe they put the market research or under R&D as well. So depend to the company also. So but this the guideline or basic typical sales and marketing department in manufacturing. So after we get the design, complete design, so we pass over the design either to the production side or manufacturing planning. So normally we pass the information to manufacturing planning, bill of material, to do the documentation, the planning of the production. So they design the process and the the process planning, the master production scheduling, to make sure the process, the product can manufacture, can produce based on planning what they have, or they can do a the planning for the materials and the requirement for product. So the process planning consists of determining of the sequence of individual process. So when they have a product complete, they need to find out the assembly or the sequence of the process, and then the manufacturing engineer or industrial engineer or production engineering, they are responsible for the process planning and related technical details. So they do this one and then pass over the information to the production side. So this one, management planning, they pass to the production side the procedure, because the procedure, this one is the operator here will follow the procedure. The machine also, they need to follow the procedure to operate. And then they have also master production scheduling. So master production scheduling is a listing of the product to be made. So when they are to be delivered, and what quantities, the order quantities by the customer, and then the raw material need to be planned, and then the raw material already available in the warehouse, for example. So the material we need to order again. So they refer to the master requirement planning. So in addition, the master schedule must not list more the quantity or the product than the factory can capable to produce. So normally in the production planning, they already know the manpower, the machine capability in their production. For example, in the one shift, they can produce 1,000 units. So the master requirement planning, they cannot list out the quantity more than that, more than 10,000, for example, because the capability to do by their machine, their manpower is for the one shift only up to the 10,000 units. So they can plan for double up the quantity, for example, for 20,000 based on double up the manpower, or buy a new machine to cater the other volume of production, or run the production based on 2-shift production. So that is can do in the master production scheduling. So when we get the schedule, the planning from the manufacturing planning, they can pass the information to the production side or to the manufacturing support system. The support system, also called as a manufacturing control. So manufacturing control in the production system, they have manufacturing control and then product facilities side. They interact each other. The information goes to the production, and the information from production go to the manufacturing support or manufacturing control system. This is I show you in the beginning this slide just now. So this is a manufacturing support system or manufacturing control. So they concern with the managing and controlling the physical operation in the factory. And in the factory, we have machining, we have tooling, we have people inside that one. So they managed by the manufacturing control engineer. So information also flow back. So they will flow back to the manufacturing control, or manufacturing control can flow the information to the production. So they have both two-side communication. And then include in the manufacturing control function, there are shop floor control, inventory control, and quality control. They have three control. For the shop floor, they deal with the problem of monitoring the progress of the product as it process, assemble, move, and inspect in the factory. So the dealing with the monitoring of the progress in the process, in the shop floor. But one more, the most important one is the inventory and quality. So the inventory is to attend to strike a proper balance between the danger, the limit of the inventory. They have a limit. They call it danger limit. So the stock inside the production, the warehouse in the production also based on the inventory control. So if we keep the stock at the lowest, meaning the lowest stock, we will be affect the production as well, because maybe the fast moving production need the 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 stock in time in the production. So when the stock shortage, so the production will stop. So that's why they call it the critical or dangerous the unit. They have to set how much the minimum requirement of the stock should be have in the inventory. So if too high, they will involve with the cost, because they need to order, they need to purchase the material in earlier. So we need to pay the order, the cost, the quantity of the material. So the money or the part we'll keep in our warehouse. So the money is there. So we already involved with the cost there. So to make a better balance on the material inventory, the inventory control department or engineer need to study the right inventory should have in stock. So this one also the right quantity of material to order and when to reorder again based on their monitoring or based on their studies in terms of the customer requirement, in terms of the machine capacity, so in terms of the production speed as well. So if the what I call it, when we go for the next chapter, we learn in the lean manufacturing or agile manufacturing, we have learned how to use to understand the concept of just-in-time production. Okay, just-in-time production, they just don't keep material in their factory. They just have support or just have a good delivery system, transportation system to to deliver the stock exactly in time to the production site. So normally the customer, the vendor, they just produce the part and then deliver to customer in time. So that's why they call just-in-time system. So they reduce the warehouse keeping in the inventory side, the warehouse side. So they reduce the cost of the buying in the earlier purchase, and then they no need to rental the space for the warehouse as well. They need to rental because the space, when they want to keep the stock, they need to rental the space, bigger space. So that's why they can reduce the space and they can minimize the amount of money they use when using the just-in-time system. That's why the inventory control is the very important part in the production, very important part to production. And another one is the quality control. This section is to ensure that quality of the product and its component meet the standard. So the inspector or the engineer do a routine check. They make checking based on the product produced. So they make sure the product meet the standard specified by the product design engineer. So the specification of already there. They need to follow. The product should achieve the minimum standard in the design. And then the activity Normally they will perform inside the line. They have a machine by machine. After they produce, they can do a minimum inspection, but at the end they have also a quality check to do the final inspection and testing the performance of the product itself. They have to test the tolerance, to test the performance, to test the appearance, so whether they meet the quality or not. So that is a very important before the product go to the packaging side or deliver to customer. If the product go through or pass to the customer with the defect, for example, so that is very costly because we need to go to investigate the customer side. What is the problem? We need to replace, to bring back to the company and then bring the new product and then replace by our own cost to their production side. So I also facing this one during I'm working in the Malaysia last time. So we make alternator motor, alternator for the car. So when we making, so they have an IC regulator. So during assembly, they have, for example, they have 4 bolts to tighten the IC regulator chip at the alternators. So when the operator tighten the bolt, so the tightens torque always monitored by the operators. So they need to tighten with the spec given by the drawing. If not, that one become electric, the short circuit or the malfunction of the alternator as well, because the IC regulator, they control the alternator itself actually. So during the process, they have tighten at the machine side, but at the final, we have a endurance check or testing of the alternator. Is it working or not? So the current, we monitor the current flow inside the alternator. So if everything okay, we pass to the customer. We pass to the warehouse and the packaging and then pass to the customer. So sometimes we have claim from customer. So the customer have problem in the testing our alternator, for example. So when we go checking, we see that inside the alternator they have a access screw. So we have 4 screw, but we have 1 access screw inside the alternator. It's not tightened but drop inside. So that one become a big problem because when alternator spinning, running, they have rotor inside. They will give a short circuit inside that one. We burn the alternator. It's good to detect in earlier. If not, there might be bigger problems, burning, whatever. So we go there to replace the alternator with our cost and then do an investigation, bring back the alternator into our company and then do a postmortem to find out why this happened. So from there, we make a procedure to revise our checking procedure, our screw tightening procedure. So that is how we work. But when we facing this problem, the quality is very important part to monitor, to make sure the good product or the safety of our product can be delivered safely to the customer. So manufacturing system is an approach to the making product. So the approach to the making product. So we need this system. So how much the product needed, we can do a calculation. We can do the study based on our capability, manpower, machine, material, the duration of the time, 1 shift or 2 shifts. So we can do a proper planning in in our production side based on this system. And then how quick the product must be produced. So based on order demand from customer, so how quick our machine, our manpower can produce the product, we can study and can have data on that one. We can have proper planning. How unique of the product must be ensure sufficient to the customer. Manufacturing system include custom, assembly, flexible, and intermittent, and then just in time system and lean manufacturing system. So this can be done by manufacturing system. So we can use a computer or the system to make to approach in the making product in good way and good system. So for assignment, we will have one assignment for group assignment. So the group one group for the group MEPA mechanical, they have 22 students for group A and 22 students for group B. They should divide by 4 groups, 5, 5, 6, 6 each for one group. So only group A for group A student, then they can divide inside their own group only, cannot mix by group B. For this goes also for the mechatronics. They have 11 students, so 2 groups, 5 and 6. So the topic of the group, the topic of the assignment will be announced by next week, 18, in the tutorial time. So I will explain the topic, format, and marketing scheme for this assignment. So I think that's all for our class today. So any question we can discuss later. So you can ask me anytime. Thank you very much. Assalamualaikum and thank you very much.